Hello back, everyone. A few technical issues as we discussed on the chat. So just a word. Don't worry for the previous talk. Unfortunately, we were not able to make it because of the internet. But what we will do, as proposed by Jim, will be to record the session and the talk with Bastien and Remy, and we will publish that video on YouTube in the following days. So you will have access to that talk afterwards. But hopefully we're back, and I'm thrilled to host Adrianna Chang. She's working at Shopify in Canada, and I wanted her to be here because she is about to share her experience in applying the Strangler Fig Pattern. If you don't know that pattern, she's going to explain, but basically it's when you want to transition from an existing legacy system to another one without doing a big bang rewrite. That is very risky. So there is a lot of theory about that. I've wrote about that too, but having experience from a big company in production from the trenches, it's rare. And Adrianna shared that experience in a blog post, and there are more than what's in the blog post, and she's about to share that with you now. So without further ado, Adrianna, the stage is yours.
Hi, everyone. Really excited to be here. So as Nicholas mentioned, my name is Adrianna. I'm from Shopify, and today I'm going to tell you all a little bit about how we used a refactoring pattern called the Strangler Fig Pattern to refactor a core piece of our platform at Shopify. So to start a little bit about me, I started at Shopify in 2016 as an intern, actually, while I pursued an undergraduate degree in computer science at Carleton University here in Ottawa, Ontario, where I live right now. So I've been with Shopify for just over 4 years now. For those of you who maybe aren't familiar with Shopify, we are a commerce platform. Our mantra is make commerce better for everyone. So whether you're kind of a small mom and pop shop or kind of a more recognizable big brand, we believe that anyone who wants to be an entrepreneur should be able to do so. So Shopify provides a extensive, powerful platform so that merchants can really focus on their business while we take care of the rest. So at Shopify, I am on a team called Code Foundations. We jokingly like to refer to ourselves as the code healers of Shopify. And our mission is to make fast and scalable commerce applications easy to build, maintain, and refactor. So Code Foundations is actually split into two different parts. We have our Ruby and Rails infrastructure teams. They focus on the maintenance and development of the Ruby and Rails open source frameworks. This is actually where I'm working at the moment, so getting to do a lot of open source work with the Rails community. But I actually spent well over a year working on the other half of Code Foundations, which is a team called Architecture Patterns. Architecture Patterns aims to ensure the health of our Rails code bases, primarily our core Rails monolith, which is pretty well known for being one of the largest Rails applications in the world. And so Architecture Patterns does this primarily by establishing patterns for good software architecture and refactoring strategies, similar things, but also by educating and empowering other developers about good code health. So this is where myself and my team experimented with using the Strangler Fig pattern to refactor our code base. And that's kind of the story I'm going to be sharing with you all today. Okay, so let's talk shop. As a commerce company, you might guess that one of our core domain models is the concept of a shop. It's in our name, Shopify. And indeed, if you were to go into our main Rails code base and find the Ruby class shop.rb, you would find the shop model. Yeah, here it is. It is a 3,000 plus line file. In traditional Rails fashion, this single model defines business logic and associations and validations, callbacks, the whole works. So there's a lot in there. It's kind of a lot to digest. In the beginning, shop's responsibilities were a lot clearer. The definition of what a shop was, was clearer. It was simpler. But today, commerce has evolved a lot. Shopify's platform has evolved a lot. And we're at the point where it's no longer clear what part of our commerce domain shop fits into, what it represents. And if you go into shop.rb and you try to figure it out, it becomes even less clear because there's just so much in there. Is it an online storefront? Is it a physical business? Is it a merchant? We're not really sure how it fits into our system. So yeah, this is kind of a code smell. There is the concept of a big ball of mud in software, and shop is definitely a big ball of mud. So that term is often used to describe code or architecture that is lacking structure, doing too much, and as a ball of mud would kind of continue to grow as it spirals down a hill, big balls of mud in software also tend to be ever growing. So yeah, this is a code smell. The fact that shop is so large and tangly indicates that there's a deeper problem in our code. Shop has too many responsibilities, its boundaries are unclear, and because we don't actually know what shop is responsible for, it becomes a really good candidate for the place where just like more stuff gets shoved because, hey, this kind of looks like it could fit in shop, so more code gets added to shop. And kind of the other challenge that comes with the shop model is because it is such a fundamental piece of our domain and it's been there from the beginning, it's coupled to a lot of other parts of the code base. So what are some of the consequences of this big ball of mud? Well, it's slow to test, it's difficult to understand, and it's really hard to change, both because it's difficult to understand, so it takes a long time to get in there and figure out what change you actually need to make, but also because it's so tightly coupled to other parts of the code base that trying to make a single change in shop can often result in, this cascade of changes throughout the code base, and it just becomes a dependency management nightmare. So, making shop less muddy. As I mentioned, my team, we were supposed to be advocates for clean, scalable, resilient architecture in the Shopify code base. So we decided that it was, in our mission statement to try and tackle shop.rb and refactor it a little bit, make it a little less muddy. But shop is a 3,000 plus line file, as I showed you, so it was really hard to know where we could even start. So in comes Flog. Flog is essentially just a Ruby gem that shows you which portions of your code are the most torturous. A little dramatic, I know. But yeah, it's basically just a static code analysis tool. You run it on either a directory or a file in your code base, and it is going to compute a score for each chunk of code. It scores things based on an ABC metric. So it uses assignments, branches, and calls to basically calculate how poor your code is. The higher the score, the more torturous your code is. So here we've run it on shop. We can see that one of the worst offenders in shop.rb is the section at the top here, shop type store settings. And this was kind of a section in the shop model that contained like kind of global attributes related to settings on a shop and related behavior. The kind of specifics of Flog aren't too important. It's not like a hard line or anything. It's more just meant to be kind of a general guideline. If you are feeling really overwhelmed by, starting a refactor and you need some guidance, it can be a good tool. I've also linked to the Flog webpage at the bottom of the slide, so definitely go check it out if you're interested and you're working with Ruby or a Rails code base. So yeah, we identified that type store settings was maybe a good first place to start look at extracting. So then the question became, okay, we know where we want to start and we know we want to make shop a little bit better, but how are we going to do so? And like Nicholas mentioned in the intro, doing kind of a cut and paste refactor is a pretty terrifying thought, especially when you're working with a class like shop that is like the foundation largely of our core monolith. So this is where myself and my team, we started talking about the Strangler Fig Pattern. It was actually my first time learning about it, and I was really interested to see how it could help us refactor shop. So for those of you who aren't familiar with the Strangler Fig Pattern, it is essentially a refactoring strategy that Martin Fowler describes on his blog. If you are interested in learning more, would definitely recommend reading it. But it's basically named after these strangler figs that grow in Australia. Basically, they seed at the top of trees and grow downwards until they can root in the soil. And eventually, they kind of completely grow around the host tree. They strangle it and ultimately kill it. So a little bit of a gruesome metaphor, I guess, but it is a very good analogy for how the Strangler Fig Pattern, when we talk about applying it to code, works. So usually it is a pattern that's used to replace a legacy system with a new system. That's kind of how it is presented in a lot of cases. So we slowly allow the new system to grow over top of the old system until the old system is dead and can simply be removed. So our use case for the Strangler Fig pattern is actually a little bit simple because we weren't trying to, migrate over to a new service or anything. We actually just applied it in the context of trying to refactor a large object. But it still remained a really good strategy for refactoring code because it allowed us to extract these super coupled things out of shop with confidence. And the fact that it allows you to make small incremental changes means that you can ship fast. If you make a mistake, it's pretty easy to just go back a step, and you can be, monitoring your application at all times, making sure that everything looks good. Okay, so we are going to get into an actual refactor we did at Shopify to refactor shop settings with the Strangler Fig pattern. I will go into kind of the breakdown of the steps we laid out for the strategy, and we'll take it step by step. We'll look at some code. It'll all be a lot of fun. So yeah, let's get started. So we broke down the Strangler Fig pattern into a 7-step process. Don't worry if this looks really overwhelming. Just wanted to kind of grab a holistic view of the process to start with, but we'll break it down step by step. So this is what it's going to look like. A side note, just kind of an aside before we actually start diving into the code. While refactoring with this pattern, we also decided to see what it would look like to split apart the business logic and the persistence logic. So for those of you who have maybe worked with Rails or are familiar with Rails, Rails has an active record framework. So usually you define classes that are active records, which mean they implement the active record pattern, which is a pattern in which objects carry both persistent data and behavior which operates on that data. So shop is an active record. And one of the big issues with shop being an active record and having this combination of business logic and persistence logic and a bunch of other stuff means that any part of the system that holds onto a shop object has access to the entire active record API, which is pretty large. So we decided while doing this refactor that we would experiment with a private active record object pattern in which the business logic and the persistence logic would live in separate classes, and the persistence logic would essentially be private to the business logic class. So if this sounds kind of weird and confusing, or maybe you don't come from a Rails background, you can kind of put it out of your mind. It'll become more obvious as we're walking through some of the code what I am talking about. But just to note that the Strangler Fig pattern can be achieved in Rails while keeping these two things together in the same class. So it's not really part of the Strangler Fig pattern, but while doing this refactor, we thought it would be a good opportunity for us to experiment with this. Okay, so let's get started. We'll set up our example a little bit. Some of the details have been simplified here so that it's a little bit easy to follow, but this is pretty much an actual refactor we did to extract a setting out of the shop class. So shop essentially has a setting locked settings, and this is related to something called Shopify Capital. So Shopify has a part of the platform called Shopify Capital, which essentially allows merchants to kind of scale and fund their businesses so they can apply for a capital loan. And if they're approved, they can leverage basically money from us. So if a shop is approved for financing from Shopify Capital, we set locked settings to true. This basically just means that a certain functionality on their store is going to be locked while the merchant is taking advantage of that loan. So if we look here on the left, that's our column in the shops table. It's just a Boolean, pretty simple. And then on the right, we have our shop model. It is an application record, like we talked about. And it has these 3 methods related to lock settings. It has a reader, so we just want to know if settings are locked or not. And then we have 2 writers, one that's going to set the Boolean to true, one that's going to set it to false. So pretty simple. So the very first step in the Strangler Fig pattern is to add a new class that defines an interface for the thing we want to move out of shop. What does that look like? So if we look at the diagram on the right, ignoring the code to start with, we have this large class. It is shop. In Strangler Fig terminology, that could also be our legacy system. We've essentially identified a cohesive chunk related to these lock settings for capital that we would like to extract. So we are going to create a new class to define the interface for this thing that we're moving out. And this new class still needs to read and write data from the shops table, obviously, because that's where our data lives. Just kind of a side note about code organization in our core Rails codebase. We have a componentized codebase. So essentially, the application is broken down into components, which are modules, and each module represents kind of a cohesive piece of our platform, our business domain. So capital is one of them. Obviously, when lock settings was just in the shop model, this was in shop, but now this gives us an opportunity to kind of put this code in a place where you'd expect to find it. It helps with the whole idea of cohesion and having things, in the class where it makes sense for them to live. So we have this capital settings to lock class. It exposes a public interface that's consistent with what's in shop. So we have our locked, lock, and unlock methods. And we basically just have a private getter to find the associated shop based on a shop ID that we pass in. That's how we continue to read data from and write data to the shops table via the shop object. Okay, so the next step is to replace readers with calls to the new system. So very simple change. Instead of calling lock settings on top, we are going to instantiate a new instance of capital settings to lock, pass in the shop ID, and call lock. So with the diagram on the right, we're basically just moving our readers over, for example, this capital controller, from the shop model to this new settings to lock class. Okay, so next up, we're going to introduce a new data source if the system requires write. So we are going to create a new table. It references shop, and it also stores lock settings, which is going to be defined identically to what is in the shop table. So we have this column here. It's a Boolean. It looks the same as what was on shop, and we just have this table reference our shop table. Okay, so step 4, we're going to start writing to the new data source from our new system. So this is where we get back into the little experiment I talked about at the start, where we decided to separate business logic and persistence logic. So you might recall that the new class we defined, settings to lock, is a pure Ruby class. It's not an application record like shop was. So the question becomes, okay, how are we going to write to this new table? Because usually with application record, you add the table at the same time as the model, and then it just handles all the persistence logic. So what we need to do now is we need to introduce a new record class whose purpose is to interface with the database. And this is going to create a clear separation between the business logic and our capital settings to log class and the persistence logic, which is kind of nice to have. Yeah, so having a plain old Ruby object to hold our business logic is great because it's isolated and stateless. So it's going to be really fast and easy to test. But as I mentioned earlier, if you're working on Rails and you have a smallish class that you're extracting and you would rather just combine the business logic with the persistence logic into a single active record model, go ahead. It's not really going to change the whole process. So let's see what this looks like when we get to our code. So we start by introducing a record class that will interface with the database. We are going to create this settings to lock record. It is an application record. It is connected to the table that we defined in step 3. And we have some like validations on the data, but other than that, it's pretty simple. So now we can start writing to the new source in our pure Ruby class. So we need to update it to be able to talk to the appropriate record object. So what we're going to do is we are going to add a repository keyword argument to our initializer. We provided a default argument, which is this new record class we've defined. And then we are just going to add a private getter record, which is going to store record in this instance variable. And it is going to use repository and do find or initialize by. So that essentially finds the associated record row in our table for the given shop ID, or if none exists, it'll create one. So yeah, if you are wondering a little bit about kind of this pattern here of repository where we are like injecting the constant, the reason we did this is because we actually used test doubles in our tests instead of the actual repository class, so that we could unit test settings to lock without needing to talk to the database. So that's kind of one of the advantages of splitting these two things up, is it means your test can run without the active record database logic. So yeah, we've injected this here instead of hard coding the constant in the class. Also, I will just mention I have omitted tests from this presentation for the sake of time. But if you are interested, I do have a blog post. It is on Shopify Engineering's blog site, and it includes tests. So if you're interested in kind of seeing how we tested this, you can go ahead and give it a read. So the final step in step 4, which is to write to the new source, is to update the two methods performing writes and settings to lock to write to both the shops table and our new data source, which happens via the record object. So we wrap these writes in transactions, so we make sure our data sources stay in sync, but that's pretty much it. Okay, now that we are writing to our new data source, we need to backfill the new data source to make sure that both our shops table and our new capital settings to lock record table, they're identical. We can read from either one of them. It would be the same. So this is basically just going to look like a backfill job. We just want to iterate over all of our shop records, perform a find or initialize to get the associated settings to lock record object. We lock the shop so that we can't write to it when we're reading its lock settings value. And we perform an update to the record object based on that value. Obviously, we want to log if something goes wrong. So that's this bit down here. This is the kind of important bit that's highlighted, but beneath it, we log if the record object isn't updated successfully. Then we can run the job. After it runs, we check, we make sure that nothing weird happens by looking at our logs. We can do maybe some data reconciliation, make sure that everything looks as we expect it. Okay, step 6, we can now start reading data from the new data source in our new system now that our data source is up to date. So a very simple step. We only had one method that was actually reading data. It was the locked method. All we need to do is change lock to now talk to the record object instead of talking to the shop object. We have essentially cut off the read from the shops table, and we are now reading from the settings to lock record object as well as writing to it. And step 7. So we've made it to the last step. Thanks for bearing with me. At this point, we can stop writing to the old data source and we can delete any legacy code. So this is the step where we get to kind of celebrate that, you know, our old code is strangled. We can go ahead and just remove it with confidence. So there are a couple pieces to this step. So let's get a visual for what's going on. If we look at the left, our new system, if we look on the left, shop no longer needs that code that we have now extracted, so we can delete it. We can delete data from the old data source. Our new system no longer needs to read from or write to the old data source. And we should be good to go. So this is what settings to lock looks like right now. We still have our double writes happening. They are wrapped in transactions. We can go ahead and remove those writes. And now that we are no longer talking to the shops table, we don't need this shop getter. We don't care about the shop object anymore. So this is what it looks like after. Very simple. We just have our lock unlock, which use the record, and we have our record getter. So we can now also drop the locked settings related methods from the shop model. And then finally, we can remove the column itself from the shops table. So that's it. We are done. To review, this was the 7-step process to refactor our code with the Strangler Fig pattern. So the first step was we defined a new class. This new class had the API for the thing we wanted to extract out of our large class. We then moved readers over to use this new interface instead of going to the original legacy object. We defined a new data source, so that was just the creation of a new table. We started writing to our new source in tandem with writes to our original data source. We did a backfill to make sure our data was in sync, did some reconciliation, made sure everything looked like we expected. We began reading from the new source, and then we deleted old code. So we deleted the code we'd extracted. We got rid of the data from the original data source, and we updated our new class to not talk to the original data source. So one thing before I wrap up, I will talk a little bit about stopping the bleeding. So one of the big issues we had with Shop is that it's a very high trend class, so changes are being made to it pretty often. So yeah, it was quite discouraging to be, doing all these lengthy multi-step refactors to try and reduce shop size, and then we'd see like other developers come in and add new code, new features to the class. So we decided to leverage a tool we have internally at Shopify called the caution tape bot. It's essentially a GitHub account controlled by an internal tool we built, and it monitors pull requests being opened on GitHub and uses a collection of rules to take action against ones. So these rules can be like the repository a file was opened in. It can be the name of the file. It can be PR contents. It can be a combination of these things. So we wrote a rule for caution tape bot that would tell it to monitor the shop.rb file and watch for new additions. In response, it would ping our team and also offer some information to the PR author about the work our team was doing to refactor and why maybe it wasn't the best idea to add more code to shop. And we actually had a lot of success doing this. All of the time we realized people were just putting code in shop because they thought that that's where it was supposed to live, and they didn't know it was okay to kind of make these smaller classes to hold business logic, and they were really just following suit. So it gave us a cool opportunity to educate other developers about the consequences of large objects, big balls of mud, and it gave us a chance to kind of stop the bleeding a little bit with the shop model. obviously this isn't like a super sustainable thing long term, but it did help us kind of get more people on board with the work we were doing, and it helped us to kind of share our experiences with some other developers. So the main takeaway is that refactoring large objects doesn't have to be scary. It can be a smooth, gradual process, and it can be a lot of fun with the Strangler Fig pattern. Thanks. So that's it for me today. Thank you all for listening. I appreciate your time. If you are interested in reaching out to me and chatting about anything Strangler Fig pattern related, software related, Shopify related, feel free to reach out to me. You can reach out to me on Twitter at Adrianna Chang, or by email at chang.adrianna@gmail.com.
Oh, thank you very much, Adrianna. That was great. And indeed, as you concluded, and with that, the automating that kind of feedback, especially, I guess, when you're working at such a big company like at Shopify. Of course, with my team, for example, we're only a few people, so we don't need that kind of thing. But I can imagine the challenge to have so many engineers working on the code base and automating that kind of thing. This is an incredible advice. I think we can take a few minutes for the questions. So I can see two questions for the moment in the chat.
Okay.
The first one is, how often were these changes merged to production? After each step or after all the steps were completed?
Cool. When do I answer, like starting now? Or do
Yeah,
Okay, cool. Yeah, I can answer it. So we merged step by step. So like we would basically do step 1 and then ship it, step 2, ship it. Some of them were even broken down kind of even more granular, like I think step 4, which is to kind of duplicate the rights. We even broke that down further, like we shipped kind of a new record class, and then like updated the rights separately. So yeah, you can obviously kind of merge it all into like a feature branch and ship it all at once. But I think the benefit of really breaking it down and shipping each thing individually is that you get a chance to see what's happening in production, and you can make sure that everything looks the way you expect it to look, especially if you're dealing with data. Like it was really important for us that like the data was in sync. We weren't, doing anything weird with our shop data. So we ran data reconciliation after like shipping the new rights and doing a backfill, and that just gave us the confidence that everything was working as expected. So I think the really great thing about Strangler Fig is that it does allow you to do it incrementally, and you don't have to worry about, finishing everything so that you can have peace of mind. Like you can take it step by step, and it can be an incremental process.
Yeah, incremental is key, and these 7 steps you shared, that's a good news for everyone. You don't have to complete all of them. You can get the feedback progressively, as you just said. Final question, because we're getting over the end. Quick question, which is, the shop model was more than 3,000 lines long. How large it is now?
That is a good question, and I can find it right now. It's pretty big. I mean, I think people are more aware now that that shop isn't the best place to put things, and so as much as possible, things should be placed kind of in the piece of the platform that is, most relevant. Let me see if I can get a roughish.
Yeah, also in the meantime, so usually when you do that kind of refactoring, you will notice that the code tends to be larger and more messy in the meantime, in the intermediate steps. And it's only when you reach the final stage, when you can delete the code, that you reap all the benefits of it. So it is normal if in the meantime it looks like more code and more complex code.
Yeah, so I do have a number. It is less than 3,000, so it looks like we have trended in the right direction.
Hmm.
But yeah, that's a really great comment about kind of being in that intermediary state. It can be, a little anxiety provoking to be like, oh, well, now I have, two tables and I have two rights. And um, so I think just like keeping your eye on the end goal and like the knowledge that things will be a lot better if you take it to the end of the refactor. And I guess the other thing too is if you are kind of nervous about moving data around, you can still kind of apply a version of the Strangler Fig pattern and really just like wrap an object, like we were doing, like wrap an object, and then you have the business logic at least in a different class. So with the example I showed today, we could have even stopped at like pulling out those lock settings methods, and we would still hold on to a shop object, read and write from the shops table. But at least then you have like business logic is in a separate class. It still makes things better in the long run, and it can be a smaller refactor and you don't have to deal with moving around data. So that's also kind of an alternative.
That's great. Well, thank you very much for your time, Adriana, and for all of this. So we're going to take a small break, and in 10 minutes, we're going to get back with our next speaker, who is actually going to talk about mastering legacy code and doing changes incrementally too. So yeah, it's all about refactoring today.